So today we're going to talk about real life examples of when we use exponential growth or decay formulas. First, we're going to start with exponential growth. That's when a quantity exponentially increases over time. And if you look very carefully at the formula, you will see something very interesting within these parentheses. So the formula is f of t equals a times the quantity 1 plus r to the t power. A is initial amount. R is growth rate. But your rate has to be as a decimal, not a percentage. And then time, which will be given in years. So what's interesting about the inside of this parenthesis is that the base of the t, when you're looking at it as an exponential function, is greater than 1. And that's how you know that it is exponential growth. So let's look at the first example. The original value of an investment is $1,800. That means that your A is $1,800. If the value has increased by 7% each year, that means your R is 7% as a decimal, which is 0.07. Write an exponential model, an exponential function to model the situation. Then find the value after 15 years. So t will be 15 years. So let's plug it in and figure it out. First, to make the function, we do not plug in time. They just want to know, what would you build? I would build f of t is equal to 1,800 times the quantity of 1 plus 0.07 to the t power. However, we know what we're plugging in for t. We are plugging 15 years, which means I'm going to plug it in for the t up here as well. And the inside of parentheses can be condensed into 1.07 to the 15th power. Now, if you do all the math, it should come out to approximately $4,966.26. Oh, sorry, that dollar sign's too close. And there you go. That is your answer. So it seems pretty useful for real life situations. So now we're going to go on to the next problem. So the next problem, we're modeling how many kids are enrolled in a high school. So first we're going to do our givens. All right, so our first given is how many students were originally there? 972. Increased by 1.5% means we're using exponential growth. And we're going to try to find the students in 2014 as compared to 2002. So let's write down our givens. Our initial amount is 972 students. Our rate is 1.5% as a decimal. Don't forget, that's the same thing as moving it 2 places to the left. And then you can clearly see it will be 0.0145. Sorry. And your time would be the time that elapsed from 2002 to 2014. That means that is 12 years. So So be careful what year they tell you that they started. So if you were to plug it into the equation, you would get f of t is equal to 972, open parentheses, 1.015. I have the 1 from the formula and I added it to my rate to the t power. But since we know we're going to plug in 12 years, I'm going to go ahead and do that. So I'm going to plug in 12 years for my t exponent. And if you calculate it carefully on the calculator, you will get 1,162 students. And that's how you do exponential growth. Next, we're going to talk about exponential decay. An exponential decay is when a quantity exponentially decreases over time. So this formula happens to look very similar to the other one, where A is still the initial amount, R is the decay rate in decimal form, and then T is time. But notice the only thing that changed here is the minus sign. And that's because when something decreases, the value inside here will be less than 1, which means that it would be like our first lesson, where B is less than 1, it means it's decreasing. A decreasing function, same thing as a decay function, things are lowering. So let's talk about our first one. An investment of $12,000 is losing value. Once they say the word losing, that means it is exponential decay at a rate of 4% each year. So I'm going to write down A is equal to 12,000. The rate in decimal form would be 0.04. And we have one more piece of information, time. And our time will be 9 years. So according to the formula, f of t equals 12,000 times the quantity 1 minus 0.04 to the t power. And then we're going to actually plug in 9 for 9 years and see how much this person has in his investment after losing for 9 years. So we're going to plug in a 9 here. And we're going to find out how much money he has left after initially investing 12,000. 1 minus 1.04 is the same thing as 0.96. So all I did was combine like terms inside the parentheses. Now if you put this carefully in the calculator, you will get approximately $8,310 with 41 cents. That poor guy went from $12,000 to $8,310.41. Okay, and then the last example for this page. This last example uses a pretty good word. So Mark, you bought a brand new car for $35,000 in 2008. If the car depreciates like the prefix D as in decrease, that means this is definitely exponential decay. Depreciates means decrease, which means decay. And it depreciates 8% each year. And they want the value of the car in 2015. First, what is your A? 35,000. What's your rate in decimal? 0.08. And then your time. Your time has to be the difference between 2008 and 2015. And you find the difference, it is the number 7. So first, let's show them the formula. The formula would be f of t equals 35,000. And then it would be 1 minus your rate, which is 0.08 to the t power. And now for t, we can plug in 7 years. And after you plug in 7 years, you can see that it will depreciate because 1 minus 0.08 is 0.92, which is less than 1 to the 7th power. And it is going to decrease to $19,524.63. And that's how you do it.